Hello, welcome to this MEI M1 video where we're going to be looking at a question involving connected particles. This is June 2011 question 8. So let's have a look through the question first. We've got a trolley of mass 8 kilograms which has rusty axle bearings. That obviously is creating a resistive force, and it's initially at rest on a horizontal floor. The trolley stays at rest when pulled by a horizontal string with tension 25 newtons, and we have to find the magnitude of the horizontal resistance opposing the pull for 1 mark. Moving on to the second part, we have another trolley, D, connected to the original one by means of a light horizontal rod. The string now has a tension of 50 newtons and it's at an angle of 25 degrees to the horizontal. We have to work out the magnitude of the total horizontal resistance acting on the two trolleys and also the normal reaction of the floor on trolley C. That's 2 marks and 3 marks. Moving on to part 4, we're told now that the axle bearings on the trolleys are oiled, and so the total resistive force to the motion is 20 newtons. The two trolleys are still pulled by the same string as shown in the previous diagram. We then have to work out the acceleration with which the trolleys would be moving. 3 marks. And the final part of the question, we have a new situation where the same two trolleys are on a slope of 5 degrees to the horizontal and they're initially travelling down the slope at 3 metres per second. We have resistances to motion of 15 and 5 newtons on D and C, and there's no string attached in this situation. The rod is parallel to the slope, and we have to work out two things. We have to work out the speed of the trolleys after 2 seconds, and we also have to work out the force in the rod and state whether this is a tension or a thrust. 9 marks. So let's get started on the first part. We have a trolley standing on a horizontal ground, 25 newton force to the right, pulling it forward, but we're told that the trolley stays at rest. State the magnitude of the horizontal resistance opposing the pull. Well, the resistive force will be the same as the horizontal force trying to move the object forwards, and so the answer here is just 25 newtons. Moving on to the second part, we've got a situation as shown in this diagram. The rod is horizontal to the ground, and we have the string at this angle of 25 degrees that we saw earlier. We have to work out the magnitude of the total horizontal resistance acting on the two trolleys. So that would be opposing the pull in the left-hand direction. So if we have a look at this forward force that's wanting to move the object over to the right, we know that that would have a magnitude of 50 cos 25, resolving to find the horizontal component, and so that would be equal to the resistive force. So working that out, it works out to be 45.31, and if we round into 3SF, that would be 45.3. So that's 2 marks. For part 3, we have to work out the normal reaction of the floor on trolley C. So I've just taken one half of the diagram here. I've removed trolley D, and we'll just have a look at the forces acting on trolley C. So what would there be? Well, we're looking in a vertical direction if we're looking at normal reactions. So there would be a normal reaction acting upwards, shall we call it R. We'd also have the weight acting downwards, which in this case would be 8G. And then this force will also have a vertical component upwards, and that will be 50 sine 25. So if we resolve vertically, we know it's not moving vertically, it's in equilibrium, and so we know that the resultant force will be 0. So upwards we've got R, and we've got 50 sine 25. The 8G is in the opposite direction, so it's minus 8G, and we know that the resultant of all of that is 0. Rearranging, R will be equal to 8G minus 50 sine 25, and working that out gives us 57.26. So if we round into 3SF, it will be 57.3 newtons. So that's 3 marks. Moving on to a slightly different situation, then in part 4, the axle bearings of the trolleys have been oiled, and so the total resistance is now 20 newtons, so it's been reduced. Two trolleys are still pulled by this 50 newtons force at an angle of 25 degrees, and we have to work out the acceleration of the trolleys. We can assume obviously that they will be accelerating that way. So we're going to have a total resistive force. We're told in the question that that's 20. And we need to work out, using F equals MA, what would be the acceleration here. So let's have a look at the resultant force. To start off with, we have 50 cos 25 to the right, and a 20 newton force acting to the left, and that's everything that's acting horizontal. We can ignore the tension or thrust in the rod, because we would have let's say a tension acting backwards on C and the same force acting forwards on D, so they would cancel each other out, so we don't need to consider those at this stage. So that's the total resultant force horizontally, and that is equal to the total mass for the whole system, which is 18, multiplied by the acceleration. And if you go through and work that out, the acceleration works out to be 1.406, and again rounding to 3SF, 1.41 meters per second squared. So again, that's another 3 marks there. And then moving on to the final part of the question, this is where the two trolleys are on a slope, 5 degrees to the horizontal. We're told an initial speed of 3 meters per second, and we have to find the speed at which the trolleys are moving 2 seconds later. So we're thinking probably some kinematics is going to be involved there. So let's focus on that part first. So we've got 2 resistances to motion described in the question here, 15 on D and 5 on C. There's no string attached in this case. We've also got the weights involved. For D, that will be 10G, and for C, 8G. And both of those two will have a component down the plane. So if we do F equals MA in the direction of motion, which is down the plane, and let's look at the whole system. So we'll look at both trolleys together. So the 10G will have a component of 10G sine 5 degrees down the plane. Remember, this angle here to the perpendicular would be 5 degrees, and the same here, 5 degrees. So we're going to have down the plane 10G sine of 5, and we'll have 8G sine of 5, and then the resistive forces are going to be 15 and 5, so that's everything acting along the plane, and that will be equal to the total mass, 18, multiplied by the acceleration. So if we work that out, we're going to have 18 G sine 5 minus 20 equals 18A. And if you put that in your calculator, we actually get minus 0.2569. Keep that full value in the calculator because we're going to need to use that later on. So now we know the acceleration, we now want to know the speed of the trolleys after 2 seconds. So remember, the initial speed was 3. So initial speed 3, acceleration is that value that we've just got. Use the full value. We want it 2 seconds later, and we want to know what the speed is. So using a Suvat equation, we can see here that V equals U plus AT will be the best. Initial speed was 3, acceleration, and 2 seconds is the time. So substituting all those values in, we get 2.486, and if we round into 3SF again, that will be 2.49. Let's just go back and look at what the rest of the question asked us to do. Calculate the speed of the trolleys after 2 seconds. We've done that. Find also the force in the rod connecting the trolleys and state whether this is a tension or a thrust. So let's have a look at the situation again. Weights, 2 resistances. The front one was 15 and the back one was 5. And we'd also have a force acting in the rod. Now I'm going to assume that this is a tension. You could assume it's thrust if you want to, but the way I've put it on the diagram there, it is a tension. So we're moving in this direction. We've got our weights. Now because we want to work out T, we don't consider the system as a whole because they would just cancel out. So let's have a look at one of the particles, so either C or D. I'm going to look at D. So I'm going to do F equals ma down the plane again for object D. So we're going to have 10g sine of 5, the component of the weight down the plane, subtract the resistive force of 15, and this force that I'm assuming is a tension, and that will be equal to the mass, which is just 10, because we're only doing this for D, and the acceleration, same as we had in the previous section of part 5. Now if you rearrange that, bring the T over to the right hand side and type it in your calculator, you get T equals minus 3.888, and so that would be 3.89 newtons. And what is important is that we note that this is negative, so must be not a tension as I assumed, but a thrust. So that's everything on the question. It's quite a long question from the second section of the paper. Let's go through and see if we can annotate where the marks would be allocated. So we'll go all the way back to where we did part 1. Stating the magnitude of the horizontal force, that's just a B mark for correctly stating 25. Moving on to the next part, you get a method mark for resolving the 50 Newton force and an accuracy mark for getting that correct. Moving on to the next part again, we get one method mark for resolving the forces, and then we get an accuracy mark for getting this line correct, and then an accuracy mark for the final answer. So if you recall, we were resolving the forces vertically for the method mark, correctly putting them in for the accuracy mark, and then obviously working out the correct answer there. Okay, moving on to part 4, and we have F equals ma, we were doing that to the right, and we get a method mark for applying F equals ma, accuracy mark for correct resolving, and an accuracy mark there for getting the final answer correct. And then finally on part 5 we have 9 marks here. So you get an independent mark for showing somewhere that you have resolved a weight correctly, so that would be anywhere within your working out. You get a method mark for F equals ma, and an accuracy mark, which is correct answer only here, for getting that acceleration. So that's 3 marks so far. Moving on to the next slide, we did V equals U plus AT, so we get 1 mark for doing a correct Suvat equation, and a follow-through mark here. So if you got your acceleration incorrect, you could still get this mark. So that's 5 marks, and then there's 4 marks left for the last part of the question, where we're working out whether it's a tension or a thrust. And again, we get a method mark for resolving along the plane. We get an accuracy mark here, it's following through your acceleration, so you would still be able to get that mark even if you got your acceleration incorrect. Then an accuracy mark for getting the correct tension, and then the final mark is for identifying that because the tension, as we assumed, is negative, it must then be a thrust. So that's 9 marks, that last part of the question. If you'd like to have a look at any of our other revision videos, go to our website. It's www.furthermaths.org.uk.